Welcome back to this devlog series on Lord of the Pit, the new computer game that I'm working on. Last time I implemented some basic combat, and this time I've fleshed out some of the core gameplay mechanics a bit. The game is starting to approach the point of playability. This is the main screen for the game, and as you can see, I've implemented camera motion so you can scan up and down the pit. There are some heroes queued up over here on the left, and if I press the action button, one of them starts hovering over the pit. And then I can press the action button again to drop them. When they reach the bottom, they go through the door and enter your throne room at the bottom of the pit. Right now there are no monsters in the throne room, but the idea would be then they would start fighting the monsters. Part of the game involves making the pit deeper, which involves adding more layers to it, but I haven't quite implemented that yet. And an issue that I'm already noticing is that in the queue of heroes, so you can see all these priests up here, when I take one of them, it looks like it comes from the back. What's actually happening is it's coming from the front and the rest of them are shifting up, but it happens instantaneously, so the only motion you see is from the back. This probably won't be as much of an issue when there are different types of heroes in line, but I could also maybe add some sort of tween to move them visibly when one of them advances. Now, part of the game involves adding new rooms to your dungeon, and right now I just have an example of this. So build lava room, build treasury, let's build a lava room, and then you can control where it goes and press the action button to add it. As you can see, when you add a room, the room goes on the side, and then in the middle here you have the door and an altered peg arrangement. It's actually pretty difficult to get the heroes to go into any door other than the one at the bottom, so I'm not sure if I can demonstrate them going into the lava room. Anyway, let me show you how this works. For the controls, I've defined a couple different actions in input map. So we have cycle left, cycle right. Those are used when you're deciding where to build, and they'll probably also be used for selecting different options, like different monsters to add to your dungeon or the type of room that you want. And then there's a primary and a secondary action button, which on a controller would be the A and B button. In the board node, we have the input function, and it will decide what to do based on both which action is being pressed and also on the current state. So I've added a pretty simple state machine here. There are all these different states, and the game reacts differently to your button presses depending on what the current state is. So for example, when you press the primary action button, if we are in the idle state, then one of the heroes from the queue will be put into scanning mode, moving back and forth above the pit to drop. If we're in scanning mode and you press the primary action button, it will drop that hero using this drop ball function, which just instantiates a ball, adds the unit associated with the hero to it, and then drops it. And if we're in the placing state, which is when you're deciding where to place a room, then whichever sector is currently selected, it will replace with the room. Separating things into different states is pretty useful for avoiding bugs. That way you don't run into problems like having a hero start scanning while you're trying to place a room. This is what the door scene looks like. Door is an Area 2D node with a timer attached to it. When a ball enters this zone, the timer starts counting down, and after 1 second, if that ball is still in that zone, it destroys whatever ball is at the door, and it emits a signal containing the unit information, which can then be read by the room to instantiate the battle avatar for that unit inside the room. And then, of course, it also deletes the ball. Now, I'm not quite happy with this, because one flaw of this approach is that it's looking at when a body enters, and it's storing that in this ball at door variable. And so if you have two bodies enter, then one of them is going to be ignored, which is potentially a source of bugs. So I'll have to either fix that, or I'll just have to make sure that there's never more than one ball on the screen at a time. You might notice that the door also has this static body 2D attached underneath. Here's the collision shape. That's this purple, green, and orange bit here. You can see thematically it's just this sort of wooden curved platform. And that just helps to catch units that fall into the door so that they don't keep going. in order to move the camera, I added this camera 2D node to the board and attached a camera controller script. The controller script doesn't do a whole lot. It basically reads the axis, which is referring to the strength of the up and down controls. If you're on a keyboard, this will be constant. But if you're using a joystick, the value of axis is going to depend on how hard you're pressing on that joystick. And then I have this line here, camera position equals camera get screen center position right before this. This is a hack because an issue I was running into is that when the camera reaches the bottom of the screen, and when I say bottom of the screen, what I mean is the camera has these limits in pixels for how far it can go, which are modified when you add new layers to the pit. But when the camera was reaching the bottom of the screen, there was a delay when I turned the other way to go back up. And that delay is because the position of the camera continues to advance. So if we look at the controller, we can see I'm adding to the camera position. When it reaches the limit of the screen, the camera looks like it's looking at the same place, but its position is actually still moving down. So when you start moving back up, there's a delay before the camera visibly starts moving again. And in order to solve that, what I had to do was fix the position at whatever the center position currently is before moving the camera. So if you try to go past the bottom of the camera, it just resets it to its current position. And there might be a better way of doing this, but I don't know what it is. Now, I was originally going to have this complicated generalized system for placing doors in arbitrary locations and then linking them to rooms on the side of the pit in arbitrary locations. And then I realized that I could just have some prefabricated blocks and swap them in for each other. So this is an empty sector. It's a generic section of the pit. You can mirror it over the y-axis to the other side, and each layer of the pit is made up of two of these. And when I install a new room, what's going on is I'm deleting the empty room and I'm pasting in these pre-made scenes of the lava room here and the treasury here, which have their own peg arrangements. They have the room off to the side here. They have the door, and of course you can change the position of the door here. And instead of having to have this complicated mess of code, I have barely any code here. All I need to do is define new scenes for each room type. So I think the general lesson here is that often there are times when we run into problems that seem complicated to solve, and sometimes you can just change the mechanics slightly, put some restrictions on what players can do, and it will make your job a lot easier and possibly make the game more fun. Because these prefabricated rooms open up a lot of options. Like, for example, consider the treasury here. Now, right now, these are just normal pegs, but perhaps it could have special pegs outside that give you coins whenever something hits them. So suddenly building a room isn't just, okay, we have a treasury here now and it has some effect. It's also, oh, we're changing the pegs in the dungeon. That green selection box, by the way, is just a square. So you can see it's a color rectangle. It's invisible. And when you're cycling between different building locations, there's a list of empty sectors where you can build, and there's a currently selected sector. And as you cycle through them, all it's doing is setting the position and scale of this selector node to be equal to whatever sector you've currently selected, which is good enough for now, but I think it would be nice to show a preview of what you're about to build. One refactoring change I've been making is to replace preload statements with packed scenes. In previous videos, you might have noticed that when I wanted to instantiate a node, I would preload, I would write preload and then type out a path to the location of the scene. This is fine for rapid prototyping, but what I prefer to do to make things more maintainable is export a packed scene. So export variable packed sector packed scene. And then in the inspector view, you can see packed sectors right here, and you can drag and drop in whatever the scene is. So in this case, it's an empty sector. You can just put that here. And then in the code, you can just say packed sector.instantiate. So this replaces the long preload statement. And there are two reasons I like this. First of all, this is an example of dependency injection. The code is relying on something outside of the code, and I would rather inject that from outside the script as opposed to hard coding the path in the script. But the other nice thing about it is if you reorganize the location of the scenes in your project, that will break any hard-coded paths, but it won't break this import. Godot will just update this to reflect the new path. So it makes things a lot more maintainable when you rearrange your project a lot, which I do. And I think it also just looks cleaner. I don't like having long strings in my code. And that's basically where I'm at. I think probably the next thing I will want to do is start creating some menus for choosing monsters and rooms and adding progression. Anyway, thanks for watching.